I just see clouds, man. By the time we're done here, you will understand the best way to build a network for east-west traffic flows. What? I didn't even know there was a north-south, right? That's what we're going to talk about. Up till now, we've been talking about the 2- and 3-tier architecture, which is the typical business/enterprise network design. And I want to jump up right now, jumping up and down and saying, I'm not changing the idea that there is a best way of building the network. I'm just expanding your thoughts to say there are other ways of building some kind of networks. Here's what I mean. When you build this network, it is really optimized for what's known as north-south traffic flow. That is, down here, what kind of things are plugging in? Computers, right? Printers, stuff that needs to access the network. That's where the name came from. And it'd be pretty weird for computers to start accessing each other at this layer. You're not going to have this guy start communicating to that guy and be like, hey, let's share our MP3 music collect. I mean, you might, but it's not normal. That's known as an east-west traffic flow. This model is designed for north-south, right? We plug our servers up here. We plug our internet routers up here, and we've got redundancy because that's what we sold, Mike. We've got all of this stuff. So all of that traffic flow is like up, down, up, down, up, down, up, down. You get the idea, right? Up, down equals north-south. But the fact is, the world is changing. It's changing. Actually, I just remembered when I created that slide, I wrote is changing. And then I was like, no, it actually has changed. Because if you haven't moved your resources, or some of them anyway, or at least started to utilize the cloud, you're a little behind the times. See, when I was describing Mike, our toothpick entrepreneur, and the business that he was building, I originally was talking about servers that people were accessing, and we were connecting them here at the distribution layer as Mike grew that toothpick business to multiple buildings. But the fact is, there's been a slow move over the last decade into the fluffy cloud. I am a fluffy cloud. I am a fluffy cloud. What's that from? Cars 3. You got to get some kids if you don't have some. I've got some spares if you need them. This is what people are talking about when they're talking about the move to the cloud. But what is the cloud? The cloud is simply a data center or data centers. And what is a data center? A data center is just a place where amazing stuff happens. It's essentially a place that's designed to never go down. I'll give you one example. I'm out here in Phoenix, Arizona, and for the last 10 years, I've been in a data center that was called IO Data. They were acquired. They're now Iron Mountain Data Centers. So when I moved into that place and moved a bunch of servers into there, they said our SLA, that's service level agreement, how much we guarantee that you will be online, as in you will get your money back if we don't meet this SLA. Guess what it was? Guess what it was? 100%. Like, they will never go down, and they guarantee it, like you will get your money back if we go down. And I'm talking to you 10 years later, and I've never gotten my money back because they literally have never gone down. They have power generating equipment here. They can truck in fuel. They have resiliency through multi-path diversity through all these different carriers that are coming in. Inside of here, they have power distribution units that dreams are made of, and they just have racks and racks and racks and racks of servers. And people that want their stuff to stay online will put it into a data center. And you know what? They say, well, you know what? We want our stuff to be online, but even one SLA of 100% isn't enough for us. We're going to grow to multiple data centers and have racks and racks and racks of servers and servers and servers. And before long, this gets so complex that people just go, let's just call it a cloud, man. It's in the cloud, which really just means it's somewhere that's not here. Mike doesn't have his servers at the business anymore. They've been exported. They're located in a place like Azure or AWS. Or maybe he's using Office 365 to store all of his data, which is just a more user-friendly version of a cloud. These are all known as public clouds. And I'll talk about the cloud later. The main thing I want to look at is what is in that cloud? I mean, how do you design the cloud? How do you design, let me say it specifically, how do you design a data center? Truth be told, you could design it the same way that Mike designed his toothpick business with that three-tiered model. It'll work just fine, and it has worked just fine for years and years and years. The spine leaf architecture is a fairly new architecture, at least in terms of how networks go. So we could have these racks of servers. Each one of these is 42U, right? All of these slots are just packed full of servers and network equipment, and you'll usually put your switch at the top of the rack. By the way, that's a known design known as TOR, top of rack. You've got your switch up here connecting to all the devices, and if this was an access switch network, it'd be very small. We would have just maybe a few racks that are connected together like this, and then maybe you've got your internet access coming out of this one with a couple of routers, right? But eventually, your data center keeps growing. You keep adding more and more servers, and you graduate to a distribution layer to where now you've got all of these racks, instead of plugging directly to each other, they do this kind of thing, right? Little redundancy there. This connectivity works, and that's worked for years and years and years, our typical model. And by the way, you grow to a core layer when you start going to multiple data centers. So instead of having buildings be the core, we have multiple, well, I guess that is buildings. Buildings, that's it, right? So the three-tier model works, but it needed to get faster. See, the data center is kind of unique in that we optimize, or we want to optimize, I should say, for east-west traffic flows. That is, we have all of these servers. Hang on, let me grab my pen. There we go. All of these servers that are sitting right here. And by the way, this is hard to do without going, all in and being like, okay, let me talk about virtualization. Let me talk about Stan, he's a great guy, who manages a SAN, a storage area network, right? And all of the servers in the data center don't actually have real hard drives. They store all of their stuff on the SAN so that, you can have a server go down and it stays up. And I mean, there's all kinds of madness that can happen in a data center, and I would love to dive into that, but I'm not going to. The point is, with that madness, with that design, a lot of our traffic instead goes like this. It's not so much wanting to go like this, but the two-tier, three-tier architecture optimizes for that kind of data flow, to have the data going up and down and up and down. So, spine leaf. The design is actually really simple. It's all the stuff that it supports that adds a ton of complexity. So while we're at this point where I'm just describing what it does, let's keep it simple. The spine is considered backbone only. The servers actually connect to leafs using those top of rack switches. So let's see, how can I best say this? So this might be a rack of equipment right here, right? Your switch, you probably have multiple ones, so a couple switches up at the top. Those would be considered your top of rack switches, and those are connecting to all of the servers. So same thing I just showed you on my chalkboard there, but those come up here to these switches that are known as spine switches. And here's the key difference. So think of it this way. Unlike the three-tier architecture, which kind of builds modules, like here's building 1 chunk, here's building 2 chunk, here's, and going on like that, it builds kind of independent modules. Look at the picture real quick. These guys are not directly connected. And if we added another spine switch, it wouldn't be directly connected anyway. It would be connected to all of these guys. They all are a single hop away from each other. If the server in this rack wants to access a server in this rack, how far does it have to go? Bing, bing. One trip to the spine and back down, you're there. What about the server in this rack to access this rack? Bing, bing. One trip. See, this is the key with the spine leaf architecture, is you've got connections everywhere. You keep adding more and more of these spine switches as you need to expand. But the requirement is that these guys connect to all the other leaf switches. Essentially, that means they connect to every single one of the racks. Now, you might say, doesn't that get a little crazy? Kind of like when we talked about the three-tier architecture, and I was like, okay, building, and we started seeing this full mesh madness. Well, it kind of gets crazy, but we kind of don't care because we're all in a data center. See, in the data center, it's optimized to have full mesh connectivity. It's optimized. I would love to just grab my GoPro and go to a data center with you. It's such a trip. But it's literally optimized with all these trays of cables that are just running to reach everything. So to build a full mesh of connectivity between the spines and the leaf, not a problem. And the goal that we're trying to achieve with this is lightning fast connectivity this way. And here's where it gets even better. I know we haven't talked much about routing yet, but we will. And I'm just going to plant this seed in your mind. Every single time we add another spine connection, we actually add another routed link. So when the server A over here wants to connect to the SAN, meaning all the drives that comprise the hard drives for the virtual machines that are running on server A, and if that didn't make a lot of sense, just hang with me for a second. It can utilize both of these connections at the same time, load balancing, and both of these switches can shoot it down here to this. You start eliminating a lot of the bottlenecks that we can run into with the traditional three-tier architecture. So don't hear in this video that I'm saying, oh, well, the three-tier was the old one, now we're going to the new one. No. Spine leaf is a data center design. Now, some people have started to adopt that within their businesses if they're running a lot of virtual servers and kind of doing their own little private cloud thing. That's great for them. But we still use the three-tier architecture for our business design, spine leaf for data center design. You now understand the best way to build a network for east-west traffic flows. I hope this has been informative for you, and I'd like to thank you for viewing.